Hey y'all, welcome to lesson 3.3, the structure of an atom. There are just a couple of different things we want to talk about the structure of an atom in a little more detail than we have up until this or before now. Anyway, a lot of it you probably know, but let's make sure and get it written down. Um, First, we'll start with protons. As we know, protons are positively charged. They are found in the nucleus of an atom. That's important to know. Um, they have a charge of +1, and their mass is 1.67 times 10 to the negative 27 kilograms. Extremely, extremely small. 26 zeros before the 167 there. And it's important to know that the number of protons determines the element. This is super important. That means that basically an element's identity is based on its number of protons. So, like sodium will always have 11 protons no matter what. If it has a different number of protons, it's not sodium, right? If it has 10 protons, it's neon. If it has 12, it's magnesium. But the identity of that element is based solely on the number of protons. Everything else can vary. The number of electrons can vary, the number of neutrons can vary, but protons are set. If it doesn't have 11 protons, it's not sodium. And that's true. Sodium is just my example, right? Nitrogen, 7 protons. If it doesn't have 7 protons, it's not nitrogen. Right? That is the one constant. Okay, super, super important to remember that. All right, the next subatomic particle, neutrons. They are neutral particles, which you probably could have guessed by the name. Also found in the nucleus of an atom. Because they're neutral, their charge is 0, and their mass is actually the same as a proton, 1.67 times 10 to the negative 27 kilograms. Okay, so that's neutrons. When we talk about isotopes, we'll talk more about neutrons. Remember, their number in an atom can change. Proton's number will not change no matter what. The next subatomic particle, let me raise this up a little bit, that we want to talk about are electrons. Electrons are negatively charged. They orbit the nucleus in something called an electron cloud. So you can see here in this drawing, this is just kind of a rough sketch, but the protons, the neutrons are in the nucleus. This one happens to have 17 protons, 18 neutrons, which means if we look at a periodic table, 17 protons, this is chlorine. It's always going to be chlorine. We can count the number of electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it also has 17 electrons. Anyway, so back to my electrons. They have a charge of -1, and their mass is much smaller than that of protons and neutrons. Is actually, we talked about this before, I know, but it's 9.11 times 10 to the negative 31 kilograms. So add an extra 4 zeros in the front of that number for protons and neutrons to get electrons. They are incredibly tiny. In fact, when we talk about the weight of an atom, we don't even count them as counting in because they're so incredibly small. Whereas the proton determined the element that an atom is, the electron determines its chemical properties. So the way an atom chemically behaves is based really on the electron and what those electrons are doing. And we will be talking about that a whole lot more as we go on in this semester. And the last thing about the electron that we want to say right now is that in a neutral atom, the number of electrons equals the number of protons. In order for atoms to bond together, we're going to have non-neutral atoms in order for that to happen for the most part. But in a neutral atom, electrons and protons equal each other. One is positively charged, the other is negatively charged. So in order for that to happen, for it to be neutral, obviously they need to be equal to each other. The last thing we want to talk about is some chemical symbols. That's what you see on the periodic table. So the chemical symbols are different for each particular atom. They have basically a letter or two letters that tell you what the atom is. Some of them you can tell by what they are. C is carbon, Ne is neon, As is arsenic. Other ones are named for different things. I'll say most often the Latin name, like Na is sodium, Fe is iron, because the Latin word for iron is ferrous, Ferrous, or Ric, depending on its form. But so they don't always equal exactly as Cl is chlorine, it does. But there are also two numbers that become important in the symbol for an element. The first one symbolizes the number of protons. The other one is the number of neutrons. And you'll see how that works. So here we have a basic chemical symbol. X would be the element. So you look at this example, Cl, chlorine. So that's the actual element. Then the number here on the top is called the mass number. The mass number is equal to protons plus neutrons. So if we see here in chlorine, there are 35 particles in the nucleus, protons plus neutrons, and they're what make up the mass or the weight of that atom. So that's the mass number, protons plus neutrons. Then the number here at the bottom, symbolized by a Z, is called the atomic number. And the atomic number is the number of protons. So in chlorine, there are 17 protons. In chlorine, there are 35 protons plus neutrons. So obviously, if you want to figure out the number of neutrons, and I'll just jot that in here, neutrons equals A minus Z, or for this example, 35 minus 17, which you pull out your calculator if you just know, is equal to 18. So that's how you get the number of neutrons. Mass number, protons plus neutrons. Atomic number, just protons. And then you have to do some subtraction to figure out the other.